In this lesson, we're going to talk about reflections in plane space. So the first thing we need to do is remember what a reflection is and then look at some of the properties. So a reflection is a rigid motion, so it means it's going to keep the same shape and size that flips an object over a line of reflection. So when we talk about reflections, one of the properties is that a reflection is always going to be in opposite isometry, and the reason for that is because if you look at the orientation or the order of the letters, so here I'm going to put my arrows on in alphabetical order, do the same thing on this side. See how the direction of my arrows is changing? That tells me that the orientation is changing, which means that this is an opposite isometry. And isometry, remember, means same shape, same size after you do the reflection. It doesn't change anything. So reflections are going to be the only type of transformation where the orientation changes, the order of the letters, and that's because the figures face in an opposite direction. And then a couple other properties is that whenever you have a pre-image point, so if you look at this diagram over here, point P would be my pre-image, so my starting point. If I'm reflecting over this given line M, the distance from P to the line of reflection is going to be the same. So this distance is going to be the same as the distance from the line of reflection to point P prime. So P basically goes over the line to P prime, but that distance has to stay the same. The other thing that's true is that the line of reflection will always be perpendicular to the segment that connects the pre-image and image point, so that we can draw in right angles here. I'm going to redraw that. So there's 4 right angles. So if you have a perpendicular and 2 equal parts here, the line of reflection is really going to be the perpendicular bisector of this segment. If we look at the second scenario here, which is saying that if we have a point that's on the line of reflection, well, it's just going to stay there because there's no distance from the pre-image to the line. So the distance just stays at 0 to get to the new image point. So if you start with the point on the line of reflection, it'll just stay there because you can't flip it over it. Every other point will always go flipped over the line of reflection that same distance away. So if we look at some properties here, so basically what I just said, the line of reflection is blank from each pre-image and image point. Well, the distance between the line and each pre-image and image point is going to be the same, so we call that equidistant. So it's the same distance away. And the line of reflection is blank of each segment connecting the pre-image and image points. It's the perpendicular bisector. So the line of reflection is the perpendicular bisector of that segment. So it's the perpendicular bisector. And that's because it's going to be, the segment here is always going to be perpendicular to the line of reflection, and it's cutting it into 2 equal parts because the distance on either side has to stay the same. So let's look at the next page, which is actually going to be constructing the line of reflection. So what we just said was the line of reflection is the perpendicular bisector. So I'm just going to make a note of that on top. Line of reflection equals the perpendicular bisector. Now it's the perpendicular bisector of the segment that isn't going to necessarily be drawn because it's the segment that if you were to connect the pre-image and image points, it's that segment that is the perpendicular bisector of. So if we're looking at our steps, the first thing you want to do is you want to connect any pre-image and image point. So connect any pre-image and image points. Then what you're going to do is you're going to construct the perpendicular bisector of this segment. Construct the perpendicular bisector of the segment formed in part 1. So if we look at this example, if I want to construct the line of reflection, construct means using a compass and a straight edge. the first thing I want to do is I want to connect any pre-image and image point. So that means I want to connect any pre-image point to its image. So if I pick A, that means I connect it to A prime. If I pick E, I connect it to E prime. You can pick whatever set of points you want. So let's just say I pick E and E prime. So that means I'm going to take my straight edge and I'm going to connect that. So this is the segment that doesn't really exist for the reflection. It's just we think of this segment so that when we talk about the perpendicular bisector, it's the perpendicular bisector of this segment. It doesn't really have anything to do with the two figures. So if I'm going to do the construction now, I'm going to do the perpendicular bisector of this segment. So perpendicular bisector, remember you start at one endpoint, go more than halfway, you draw your arcs. Then we're going to go to the other segment, or the other point, draw your arcs. And if I connect these, I'll do it as this green dotted line so it stands out. This green dotted line is going to be the line of reflection. Now, it does not matter what you choose for your pre-image and image points, because what ends up happening is you get out the same line regardless. So let me just show you quickly. So if I were to use D and D prime, I'm not going to actually connect them. But if you look at my compass here, so if I take my compass and I go to D prime, and I draw my arcs, and then I go to D and draw my two arcs. Oops, I just moved it. Do you see how the line of reflection would be the same? Now my line's a little bit off because I'm having trouble moving it, but the line of reflection is the same if I actually connected from here to all those points. So you only have to do one set of arcs. So you don't really need these blue ones. But just to show you that you get out the same result. So I'm going to go ahead and delete those because I only want you to see that you only need one set.